Joseph's College for Women Autonomous Visakhapatnam. Welcome to St. Joseph's open web-based learning platform. So we learn for a soulful, enriching e-learning experience. Department of Physics, St. Joseph's College for Women Autonomous presents St. Joseph's massive open online courses in digital logic design, and it is a skill effective course for degree students. I am Dr. C.H. Praveen Babu, Assistant Professor, Department of Physics, St. Joseph's College for Women Autonomous, Visakhapatnam. I am the instructor for this course, Digital Logic Design. In this topic, we are discussing about combinational logic circuits. Presently, in this video, we are going to learn about the introduction of combinational circuits. In introduction to combinational circuits, the learning outcomes from this topic is definition and design of combinational circuits, analyze fundamental building blocks, simplify Boolean functions, analyze data handling circuits, and applications to digital systems. Introduction to combinational circuit. A combinational circuit is a digital logic circuit in which the output depends on the combination of inputs at that point of time with total disregard to the past state of the inputs. The digital logic gate is the building block of combinational circuit. The function implemented by combinational circuit is depend upon the Boolean expressions. On the other hand, sequential logic circuit consisting of both logic gates and memory elements such as flip-flops. Figure shows below the combinational circuit having n inputs and m outputs. The n number of inputs shows that there are 2 power n possible combination bits at the input stage. This is the logic symbol for combinational circuit. Here we are having n number of inputs and here we are having the m number of outputs. Analysis procedure for the combinational circuit. To obtain the output of Boolean function for a logic diagram proceeds as follows. First, we have to label all the outputs that are a function of input variables with arbitrary symbol. Determine the Boolean function for each gate output. Secondly, label the gates that are a function of input variables and previously labeled gates with other arbitrary symbols. Find the Boolean function for these gates. Repeat the process outlined in step 2 until the outputs of the circuit are obtained. By repeated substitution of previously defined functions, obtains the output Boolean functions in terms of input variables. For example of combinational logic circuit, we have taken one combinational logic circuit having 3 inputs and 2 outputs. The inputs here in this circuit are ABC and the outputs are F1 and F2. Here we used 3 AND gates having 2 inputs. This is AND gate having 3 inputs and this is the AND gate having 2 inputs. And here we use 2 OR gates here. These 2 OR gates having 3 inputs and this is a one more OR gate having 2 inputs and this is the NOT gate what we use. The outputs we are getting in this circuit are at different stages. First output we are getting F2 at the here at the first OR gate, the output we are getting is A into B plus A into C plus B into C. So we are adding all these three circuits of the AND gate outputs. Next output we are getting at T1 here. The output is A plus B plus C. Next output we are getting the T2 here, that is A into B into C. Next output we are getting is T3 at the fourth AND gate, that is the output is F2 dash into T1, means F2 dash is coming from here and T1 is coming from here. Next, finally, we are getting the F1 output here with the combination of T3 and T2. T3 is equal to F2 dash into T1 here. Now we are substituting F2 dash and T1 from the previous values. Then we are getting the values A dash B C dash plus A dash B dash C plus A B dash C dash plus A into B into C. From the above logic circuit, we derive the truth table for it, and the truth table we are getting as like this. We are having three inputs and these are different output stages. The inputs are A, B, C, and the outputs are F2, F2 dash, T1, T2, T3, and F1. If all the inputs are zeros, only F2 dash is active. When C1 C input is high, F2 dash and T1 dash T3 as well as F1 are high. When the input B is high, F2 dash, T1, T3 dash and F1 are high. When B and C inputs are high, F2, T1 are high. When A input is 1, the outputs F2 dash, T1, T3 and F1 are high. When the input A and C are 1s, then the output F2, T1 are high. When A and B inputs are 1s, then the output F2, T1 are high. When all the three inputs A, B, C are 1s, then the output F2, T1, T2 and F1 are high. In previous example, we derived the truth table from the logic circuit. In this example, the designing process is different. We are going from the truth table to the logic circuit. This is the truth table. Here we are using 4 inputs and 4 outputs. The inputs are A, B, C, D and the outputs are W, X, Y, Z. According to different combinations of input, we are getting the different combinations of outputs. Circuit implementation for the above truth table. This is the circuit what we got from the truth table. Here we are using 4 inputs A, B, C, D and we are getting the different combinations of outputs W, X, Y and Z. The Z output we are getting is D dash and Y output as C into D plus C dash D dash, that is equal to C into D plus C plus D whole dash. And the next output we are getting is the X output here. The X output we are getting is B dash C plus B dash D plus B C dash D dash. We can take B dash common, then we are getting B dash into C plus D plus B into C plus D whole dash. Then finally fourth output W we are getting as A plus B plus A plus B into C plus B into D. That is, that in this two we are taking B common, then we are getting A On this topic, Introduction to Combinational Circuits, what we have learned is key characteristics, common combinational circuits, design procedure, applications, and difference from sequential circuits.